In this second lesson, we're going to look at notation that we use when we're dealing with functions. Relationships, we usually use y and x, though you do not have to. That's just sort of our standard. When we're dealing with function notation, we change it up just a little bit. We use something called f at x. And that's what this symbol here means. Really what that means is it's the same as saying y equals f at x. It's going to replace our y equals. And the way it works is, if I had something, for example, f at 3 equals 4, I'm saying when my function value gets an input of 3, in other words, when x is 3, I get an outcome of 4. Or in other words, I know that 3, 4 is a single point on my function. Okay, so if we go back to what we did in quadratics last year for a second. In last year, we would look at things like the height of a cannonball after it's fired into the air. And our relation, as we called it then, would look like this, that the height depends on a certain amount of time goes by. Well, all we're going to do now is change that. So instead of just saying h equals, we're going to say that the height at a certain time t is that equation. So for example, h at 2, I'm saying, what's the height after 2 seconds? What's the height at 2? And so just a slight little change, and we use this when we're dealing with functions. So let's look at a couple of examples here how it's going to work. So I have a graph of some sort of function. And when I give you guys something that just says y equals fx, all that means is some function. It doesn't necessarily have an equation, or maybe it has a whole bunch of equations to make it, but it's just some equation. I want to use this graph to figure out some things. So let's give it a try. Part A, f at 2. In other words, I'm saying when x is 2, where are we at in terms of the function? So if I find x is 2, that's right here, and I go down to my function, I'm at that point right there. What's that y value? The y value is negative 1. So basically what I'm saying is there's a point on my function at 2, negative 1, which I hope you could agree with there is. Okay. A common mistake, people try and say like this is f times 2, not f times 2 at all, just f at 2. It's a way of describing a position, a place in your function. Okay, let's try the next one. F at negative 1. So find negative 1, that's here, and go up to our function, that's that point right there, and I get 1. In other words, there's the point, negative 1, 1. Now, we're not going to write this out all the time, okay? We're just using it for the first time to describe things. F at 0, that would be right here. The function's at 3 at that point. And the reason we really use this is we can do things like part D. We can do some operations with functions. So I want to find f at 2 minus f at negative 2. So our function at 2 we already figured out. That was right here. Negative 1 minus, where's f at negative 2? F at negative 2 is right here. It's positive 1. So if I combine those two things together, I get negative 2. We're combining them by just subtracting. Okay, so we can pick points off of a function by using our function notation. We can also do it using an equation. All we're going to do is substitute the given x into our equation for x. So I have a function, f at x equals 3x plus 1, and I want to find f at 3. The way I'm going to do this is wherever I see an x, I'm going to replace it with my 3. So here's my x. It's 3 times x. Oh, no, not 3 times x. It's 3 times 3 plus 1. Which gives you 9 plus 1, which is 10. Now, as I said a second ago, the common mistake is people try and divide this out. Don't divide by 3. This is part of my solution. F at 3 comes out to 10. In other words, on my function, there's a point, 3 and 10, x and y. Okay, again, we're not going to show this, but that's what that means. Let's try f at negative 2. What do we get? We get 3 times negative 2 plus 1. I replace the x with negative 2. Do our math, and there's our function value. So when x is negative 2, y is negative 5. Okay, we want to be able to combine things, so let's give one of those a try. F at 5 minus f at negative 1. So think of this as two separate parts. Let's do f at 5 minus f at negative 1. So I'm using the equation twice. I'm using once with the 5 and once with the negative 1. I'm going to do both equations same time. And we're going to get 16 minus, and then we'll get negative 2 in the other one, and that comes out to 18. Okay, you guys can try the last one. F, oh sorry, I'll do this one together, it's different. Okay, I want to know x if f at x is 4. So this time they're telling us what the function value is. They're saying f at x is 4. Let's put 4 in for f at x. That's what that is. So if we do that, it's going to look like 4 equals 3x plus 1. I need to solve that. How do I solve them? Well, it's just algebra. Numbers on one side, letters on the other. So this happens when x is 1. Now if we were to try it, putting x, figure out f at 1, what would it come out to 4? Now that's a nice simple one. That was a line, an mx plus b line, if you will. We can do with more complicated things. A quadratic. We know quadratics are functions, so we know we can use function notation. Let's figure out f at negative 1. So wherever I see the x, I'm replacing with negative 1. So I'll put that in for x. We're going to follow BEDMAS. So negative 2 squared plus 2. That comes out to 4. That comes out to 6. So again, we're not going to write it, but we know there's a point, negative 1, 6, on this function, on this parabola. Okay, you guys try the next one, f at 2. And this one's a little bit easier in a way because no signs to worry about. And there's our function value. Again, we can combine things. We're using some function notation. We're going to do it twice. Oops. Try the third one. We're going to use the big square brackets again. So we'll do 3 minus 1 squared plus 2 minus negative 3 minus 1 squared plus 2. Okay, what are we going to get? We're going to get 2 squared plus 2 minus negative 4 squared plus 2, which comes out to 4, 6 minus 16 plus 2 is 18. So we get negative 12. And for the trickier one again at the end here, let's figure out what f at x plus 1 is. That looks different. We've done f at x. We've done f at 1. How do we do f at x plus 1? Well, let's take our idea. Our idea is whenever I see f at x, I replace it with a given value. So I'm going to take x plus 1, and I'm going to substitute it in for x. How's that going to look? We're going to get bracket. There's supposed to be an x, and that's x plus 1 now. Minus the 1 that was already in the bracket, that's this one right here, squared plus 2. And we're going to simplify that. Well, inside the brackets, BEDMAS, 1 minus 1 gives us 0. So we're left with just an x squared and the plus 2. Okay, so we can use algebra to do this also. Let's try the next one. Again, we got some weird things going on here. In particular, this 3 and this plus 2. If I were to get rid of those, I'm thinking you guys would know what to do. We could figure out f at negative 1. In fact, I think we already have. Negative 1 minus 1 squared plus 2. That's negative 2 squared plus 2. That's 4 plus 2. That's 6. Okay, so in other words, f at negative 1 equals 6. But that really wasn't the question, was it? The question was 3 f at negative 1 plus 2. When you come across an expression that's got extra parts and pieces to it, you might need to think of adding some brackets. This is the same as saying that. Okay? F at -1 is its own value. It's a number. We can calculate it. So we follow BEDMAS rules. Think of the brackets inside, the big square brackets. Figure out what F at -1 is. And then we got to do 3 of those. So that's going to give us 18, right? 3 F at -1. And then if I want to do all of that plus 2, I can do 3 F at -1 plus 2. Take my previous answer and add 2 to it. Well, that'll get me 20. Okay, so you get extra values. Think of it as BEDMAS. I got to do the inside brackets first, the function part first, then multiply and divide, then add and subtract. Okay, last little page here. How are we going to start applying this? So we've got water type plumbing. They charge $45 for a service call plus $35 an hour for labor. Can we express the service charge as a function of the number of hours worked? This is something we've done in grade 9. This is a linear relation, except we're going to deal it as a function now. So how should functions look? Functions should have function notation. Now I'm using F and H. Why am I using H? I don't know. I'm going to call it the hours worked. H equals number of hours worked. Okay. Well, what's my equation going to be? It's going to be $45 plus 35 per hour. There's a function notation equation for this line, as opposed to a relationship format, y equals mx plus b. Okay, what's the charge if 7.5 hours of labor are needed? So in other words, what's F at 7.5? We've done this, that's what we were doing a second ago. It's really what we did in grade 9. We're just going to approach it in a slightly different way by using that function notation as our setup, if you will. So I'll put that on our calculator. And I hope you guys got 307.50. Okay. Okay, last little piece. And this is a little tricky. So I've got a function. It's a quadratic. We know quadratics are functions. Find the values of x for which f at x equals 0. So I need to take the 0 and I need to put it in for f at x. I know they're equal to each other. So I'm left with this. A quadratic that needs to be solved. How do we solve quadratics? Now you might recall we have two formats, or two ways, methods. We can factor and solve, or we can use the quadratic formula. Now, I'm going to give you stuff you can factor. I just want to review some factoring here, if you will. Hopefully you guys remember the idea of a simple trinomial and maybe, man, I need to multiply a -15, and I need to add to -2. Can we think of numbers that do that? We can if we use the numbers -5 and 3. And in a simple trinomial, our factors are simply the numbers we just figured out. I hope this is sounding somewhat familiar. Factoring is a huge, huge, huge part of what we're going to do in grade 11. So we've spent weeks learning it in grade 10. Now we're not done. It actually said find the values of x. To find our values of x, we've got to figure out what the zeros are. You remember the idea of changing your sign when you take it out of the bracket? So x is 5, and x is -3. Okay, just a quick brief review of factoring. We're going to do lots of factoring, so we'll review some more later on. Just try one right now. Let's try the same thing in b, but this time the function's worth 33. So we approach in the same way. So 33 equals x squared minus 2x minus 15. One of the other things you might remember about quadratics, or hopefully remember, is before you solve them, they have to equal 0. I got to take that 33 to the other side. Okay, so I end up with minus 33 over here, or in other words, x squared minus 2x minus 48. What numbers work this time for man? Well, I need to multiply to -48. I need to add to -2. And the only numbers that do that are -8 and 6. So -8 and +6. Those are your factors. Remember, we want to solve this. We want to find the values of x. So x either equals 8 or x equals -6. Okay, and there's some function notation. Sometimes we're given the function value, sometimes we need to find the function value, but everything's going to be about functions from now on. And a couple questions to try again from our homework. Again, it's the handout that's on the website. You can check it out. The answers are there. If you're stuck with things, come see me. After we get through the basics, it's going to start moving a lot quicker than this.